let's record this. Okay, we're just going to take a second at the start. Just think what a percentage is and look at how we can write that out. Okay, take off this jacket, I'm a bit noisy. Okay, so what a percentage is, how we write that out, how we communicate that, and how we use that. Okay, so percentage in its simplest sort of meaning, definition, is just a number expressed as a fraction of 100. Okay, so a percentage, very simply, percentages. Okay, what we're looking at is a number expressed as a fraction of 100. Okay, so what does that mean? Okay, if you see something like 50% off, okay, that's sort of half price, they've taken half of 50 is half of 100. Okay, so they've taken that fraction of 100 off that amount. Okay, so we're a number expressed as a fraction of 100. Okay, now, see that term fraction? Okay, we've worked a lot with fractions. We've thought a lot about fractions, how we manipulate it. But how else can we write out a fraction? Okay, and that's what I mean is we can write it as a percentage. Okay, so we've been quite used to doing things like find a fraction of something. So find 2/3 of 621. Okay, so looking at that, even if I do that long division, long multiplication, so 3 goes into 6 twice. Okay, doesn't go into 2, that carries over and it goes in 7 times. Okay, can then multiply that 207 by 2. Okay, 14, carry that 1, that carries over, and then 4. Okay, so 2/3 of 621, okay, is 414. Okay, so we're sort of familiar and we've done quite a few of those types of fractions and how we work that out in regards to long multiplication and long division. Okay, so essentially, multiply by 621, we can write that or 2 times, no, that's wrong, 621 divided by 3 multiplied by 2. Okay, it's the exact same thing. Okay, so there's lots of different ways of writing it. Another way we can write that as a fraction. Okay, so if you put 2 divided by 3 into your calculator, okay, you're going to get a number, 0.6, okay, or 0.66. That 0.6 is a fraction. Okay, so we've come up with a fraction of that, or a percentage of that number. Okay, that's 621. That percentage there is convertible into okay, either or. So that 2/3 can be written as 0.6 or 60%. Okay, really 0.66, I don't know why that's simplified that. Okay, so some common percentages and fractions that we work with. Okay, if we wanted to convert one to the other, we're working with 1%. Okay, we could write that as a fraction. 1 over 100. Okay, or we could write that as a decimal. You put that in your calculator, 0.01. Okay, so there's 3 ways of communicating that. Okay, 10%, 10 over 100, which simplifies down to 1 over 10. Okay, which we can also write as 0.1. Okay, so again, it's 3 ways of communicating. 20%.
Andrew, can I ask a question, please?
Yep.
Like, you've got the top there, 2/3 or 0.6. Where does the 0.6 come from?
So if you put that in your calculator, it should be 0.66, but I don't know why my calculator's doing that.
Mine says 0.66 as well.
Do you know why? I don't know what format my calculator is, but it's 0.66 and it repeats. So it goes 0.666666. What my calculator has done, for a reason I'm not entirely sure of, is that it stopped it repeating. Which is odd. Let me change calculator. Okay, so it should be 0.66, sorry. 66%. My God. My calculator. Here's my calculator. That's what I'll do. 2 divided by 3, 0.666666. Okay, so just be careful when you press buttons in your calculator because you can change the format on it. Okay, so conversion wise, okay, working with simple conversions, percentages to fractions to decimals. Okay, another common one, 25%. It's just a fraction of 100. Okay, this time that simplifies to 1/4. Okay, so simplification, so if we simplify that right down, okay, there's 4 25s and 100, 1 in 25. Okay, you can write that. So if you put that in your calculator, you should get that result. Okay, so 1 divided by 4. 125. Odd things. Okay, 50%, probably the most common one we see. Okay, just means 50 over 100. That simplifies down to half, so when you see half of, okay, it can be written as a decimal 0.5. Okay. Less common ones, okay, below 100, 33 1/3%. Okay, third over 100, that can be written as 1/3. Okay, it's just an odd way of writing it. It's a third because those threes will just keep repeating. Okay, so you'll never get a whole number out of that. Okay, so it's just an odd way you might see that written, a third off. Okay, it's 33% effectively. Okay, it would have to be communicated like that. Okay. You can also go above 100. Okay, and that gets a wee bit trickier above that. Okay, so you can get things like 200%. Okay, it's still technically a fraction of 100. So 200 divided by 100. Okay, or 2 over 1. Okay, written as a decimal, it's just the number 2. Okay, so if we go above 100, okay, we have a number greater than 1, and we'll talk about that later on as well. Okay, and we'll give it a name. Okay, so we'll talk about how we use these decimals going forward. Okay, so it's just a case of we want to recognize that a percentage in its basic form is just a fraction of 100. Okay, some of the ones we're most aware of. Okay. Now, if we are writing out things like, we're trying to find out something along the lines of 50% of 38, okay, what that essentially is asking us to do, 38 multiplied by 50 over 100, okay. This is quite an important step to what we'll be doing later. Okay, so that 50 over 100, okay, or we could write it as 0.58. Okay, 38 times 0.58. So if you put that 58 divided by 100 into your calculator, you get 0.58. Okay, if we're asked to find 58%, we can write that as 0.58. Okay. An easier one. Okay, so if we get asked to find 20% of 50, okay, just means 50 multiplied by 20 over 100, okay, which we could also write, which would give us 10, okay, we could also write that, we could simplify that 20 over 100 down, that's actually just a fifth, okay, or we could write it out, all those lines mean the same thing, okay, it's just different ways of writing out 20%. Okay. So that 1/5 is just simplification, simplified that 20 over 100. If you put 20 over 100 or 1 divided by 5 in your calculator, you would get 0.2 out. Okay, so it's just different ways of communicating the exact same thing. Now, we can also go the other way. Okay. We can also go the other way. We can write 135%, okay, of 47. Okay, so that's saying 47 multiplied by 135 divided by 100, which gives us a multiplier. Okay. You'll see that this number that we've ended up with is bigger than our start number. Okay, so because we've got over 100%, it means we're increasing. Okay, it's getting bigger. So 100% is our whole. Okay, I think we know that. So 100% is the whole. So if we're above 100%, we're going to get a bigger number. If we're below 100%, we're going to get a lower number if we multiply that percentage.
When you say you get a multiplier, what do you mean?
So if you put that in your calculator, that 135 divided by 100, will give you this figure here, 1.35, okay, or that figure here. So the multiplier is just the decimal form of, okay, so it's the multiplier. So I'm multiplying 47 by 1.35 to get my 63.45. Okay, so 135% is a percentage, it's just 135 divided by 100. Okay, that gives me a decimal multiplier to go with. Okay, so if we multiply 47 by that 1.35, we're going to get a number bigger than 47. Okay, so 135% of something is greater than the number we start with. Okay, the number we start with is the whole. Okay, it's one of. Okay, so if we start with 100% of something, okay, if we start with 100% of 30, okay, it's just a whole, it's just 30. Okay, essentially the multiplier just becomes 1. Okay, so 100% is the whole. If it's below 100%, the number we're starting with, okay, is going to decrease. If it's above 100%, it's going to increase. Okay, and that makes sense. Okay. You can also get decimals of percentages. So if we get 78.2%, we can also do the same. Okay, so if we get 72%, 102. Okay, that's just telling us it's 102 multiplied by 78.2, and that gets divided by 100. Okay, and that will give us an odd number, but 79.764. It'll go on a wee bit. Okay. As a multiplier, that's just 0.782. Okay, so it's just different ways of communicating what a percentage is. A percentage is just a fraction. So the fractions that we've been working with, we could put that in a calculator and we'd get a decimal out. Okay, and with that decimal, we can multiply that number. Okay, a percentage is just that as well. You can change a percentage into a fraction and vice versa, a fraction into percentage. Okay. Another way to look at percentages is if we're trying to find part of a total number. Okay. This has been a very common way, so it's going to be a part or a fraction of a total number. Okay, and this has been quite common recently when you've seen in the news talking about the percentage of people that's been vaccinated. Okay, and it's given things like 80% of people in Glasgow are vaccinated, 90% of medical professionals are vaccinated, things like that. Okay, so essentially we're taking a total number, we're taking part of that and dividing them by each other. So let's just go through an example of that. Okay, so if I say in class A, 19 out of 28 people, okay, have passed. What's the percentage pass mark? Okay, so the percentage pass mark, if you put that in your calculator, okay, if you do 19 divided by 28, okay, you're going to get in your calculator 0.678. Okay, if you multiply that by 100, okay, you're going to get 68. Okay, so it's that fraction of 100. Okay, so we're getting 68%. So that 0.678, okay, I've just rounded up to two significant figures, and it's 68%. Okay, so if you put that in your calculator, you're getting a number 0.6785, blah, 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 blah. Okay. That figure there just means we're getting 67%. Okay, so 19 out of 28 pass, that means there's a 68% pass mark. Okay. Again, that's just a ratio of 100. So if we were to put that over 100, okay, if we were to write that as a fraction of 100, okay, we'd have 67.8 divided by 100. That's given us, okay, our 0.678. Okay, that's our percentage figure. Okay, that's the one we'll communicate. So all a percentage is just a number expressed as a fraction of 100. Okay, I just wanted you to see what we wrote down at the start. So it's a number expressed as a fraction of 100. Okay, so that's coming out at 68%. So if we said class B, that 21 out of 38 passing, and we wanted to compare them, okay, it's very difficult to compare just the numbers. Okay, so if we were comparing just the numbers, we would say 21 is a bigger number than 19, so more people passed in class B. Okay, but that wouldn't tell the full story because there's more people in class B. Okay, so if we worked it out as a percentage, we did 21 divided by 38. Okay, and in our calculators we're getting 0.5526. Okay, well, that's giving us is 55%. Okay, so in our calculators it's coming out as 0.552 onwards. Okay, so it's a fraction of 100. Okay, that's 55%. Okay, it's an odd way to explain it. Okay, but if you see 0.55, okay, if you just think, if you're going to multiply that by 100, you're going to get the percentage that you would write out. Okay, so if we were going to look at what class performed better, then class A actually has a higher percentage pass mark. Okay, that's how we work out percentages. Now that's been really common recently. As I said, percentages have been quite heavily publicised. Okay, but essentially that's how they're finding them out. Okay, by dividing 60 million by 70 million, they're getting the percentage of the UK that's been vaccinated. Okay, it's a fraction of 100. It's been communicated as a fraction of 100. Okay. So, what can we do with this? In that 4, okay, you look at something called calculate percentage change. Okay. Essentially, you've got a start number, and you've got an end number, and you have to illustrate or you have to show, communicate how much of a percentage that's changed by. Okay, so if we put a story question to that, we've got an average attendance. At a stadium goes from 4,310 to 5,280. Okay, we want to calculate the percentage increase. So we know it's increased, but we want to show that as a percentage change. Okay, so percentage change equals the change. Okay, so how much we've changed by over the starting amount okay, multiplied by that 100. We're multiplying that by that 100 to go from point something, okay, that we had here, 0.55, etc., Okay, to go from that point something to put it into our percent. Okay, so the change, okay, 5280 minus 4310 divided by the starting amount, which is 4310, multiplied by 100. Okay, so the change is increased by 970, dividing that by 4310, multiplying that by 100. Okay, that calculation, 970 divided by 4310, okay, it's giving me 0.225 and multiplying that by 100. So I'm getting a percentage increase of 22.5%. Okay, so that is just the ratio of 100. Okay, that's just our decimal. So if I was writing 22.5% in decimal form, I'd write it as 0.225. Okay, to get it out of decimal form, multiply it by 100 to get that. So it's that value, that attendance, is increased by 22.5%. Okay, so we've taken the amount it's changed by, so it's changed by 970, divided that by the original number, okay, to get the fraction, the decimal, okay, multiplied that by 100 to get our percentage. Okay, so that's sort of NAT 4 sort of revision. So how we communicate fractions, what fractions are. Okay, so if there's any uncertainty, okay, please have a wee look back. Okay, let's have a wee look. Oh, I can't go in that. Okay. So if you're struggling with fractions and what they mean, if you go back and look, okay, just Google BBC Bite Size National 4, it'll take you into what fractions are, okay, once that loads up. Okay, and it'll walk you through that process. In fact, I'm not looking at fractions, I'm looking at percentages. Look at percentages, there we go. Okay. So percent means just out of 100. 15%, 15 out of 100, blah, blah, blah. Okay, so if you're unsure, just go and have a wee look at that, just a wee check of that. Just get yourself comfortable. Okay, there's no problem doing that. Just make sure you're at that sort of level. Okay, so there's your percentage increase. Okay, working out percentage increase. Expressing one quantity as a percentage of another. Okay, that's what we've just been doing. Okay, tells you how to calculate your VAT if you want interested in that. Okay, and then discount calculations. So there's a lot there, okay, including a video if you're unsure of anything. So that's the sort of precursor to sort of NAT 5, okay. So that's the level you should be at, and then we take that step further. Okay, so that's just what I've just went over there. Okay, or attempted just to go over there. Okay, so that is there, there's resources there. Okay, what I want to look at today, okay, or tonight, is sort of build on that. Okay, so build on the idea of percentage increase. Okay, and we're going to talk about something called appreciation. Okay, and depreciation. Appreciation is when something goes up in value or amount. Okay, so when something goes up in the amount, okay, the number increases. Depreciation is when something goes down in value. Okay. Appreciation, common examples, savings. Okay, you'd hopefully the savings in the bank are going to appreciate at a certain level. Okay, so your savings account might have a value of 2%. Okay, 2% interest. So every year you hopefully, or that should increase by 2%. Okay, and that will continue increasing by 2%. Okay, other things that appreciate, you'd hope your house value goes up. Okay, if you're lucky enough to own a house. Okay, common examples of depreciation. If any of you own a car, probably heard the nice phrase that as soon as you buy a new car, as soon as you drive out the forecourt, it loses 20%. Okay, that's it depreciating. That's it depreciating. That's it going down in value. Okay, so we're going to look at when things appreciate and when things depreciate, and how we work that out by using percentages. Okay, and this is a really common question to come up in the exams. Okay, so it will come up every year without a doubt. Okay, so focusing on appreciation first. Okay, it's going to go up in value, we know that. Okay, normally given by the same percentage. Over a given period. Okay, and the periods commonly are year, month, okay, it could be week, day, okay, any sort of timeline. God, any sort of timeline there. Okay, so year, month, week, day. Okay, they use a variety of periods in the exams. Okay, so let's look at that. Think about that multiplier again. So I've sort of mentioned a multiplier before. Okay, and you picked up on that, Sandra. So if we have the whole sum, we've got 100%. Okay, if that increases, then we have more than that whole. Okay, we've got more than one. Okay, so if we have a whole, okay, we can say we've got one or 100%. Okay, so that's our starting point as a multiplier. We've got a whole of something, we've got one of them. Okay, that daft does that sound? Okay, or 100%. Okay, if that thing increases, so if that number increases, okay, if that increases to higher than what we started with, okay, we say that increases to a number greater than 1. Okay, and this will make sense. So if from where we start, okay, we must have number greater than 1 or greater than greater than 100%. Okay. So we know, we went through that 1% can be written as 1 over 100 or 0.01. So if something increases by 1%, we can say that we have 1.01, okay, times the original amount. Okay. That 1.01 is our multiplier. That's what we multiply by the thing we have, okay, to get our new number. Okay, so if we've got 10% increase, okay, we can write 10% as 10 over 100 or 1 over 10, okay, or 0.1. So the increase would be 1.1, okay, so our multiplier would be 1.1. Okay, so that's what we need to multiply the original number by, okay, to get our increase. Okay, and it's an odd way of writing it. It's actually easier to do it than it is to explain it. Daft as that sounds. Okay. 10% can be written as 0.1. Okay, if we're increasing, we're going at greater than the number 1, so it's 1.1. Okay, we're going to multiply it by. Okay, so let's put that in an example. Okay.
Can you put that up slightly just so I can copy that down? It's just the last few seconds.
This one?
Yeah, just there, yeah. That'll be 2 seconds, thanks.
Yeah, no trouble. Okay, so if we stick that in an example, very good. Do that. Okay, if we stick that in an example, okay, so if we say £3,000 is invested in a savings account, okay, 2% APR. Okay. How much do we have after 1 year? Okay, so first we need to determine what the multiplier is. Okay, so our initial whole is 3,000. So that's our initial value. Okay, we know that it increases. Okay, so 2% APR means we're increasing every year. Okay, so that's the annual percentage rate. Okay, so that's your increase every year. So you hopefully, savings are pretty low right now, but hopefully we're in that sort of region. Okay, so you'd hopefully see that 3,000 grow by 2%. Okay, we want a multiplier from that. Okay, so we want to multiply that 3,000 by something to get that new value. Okay, so in 1 year, we see 3,000 increase by 2%. Okay, 2%. can be written as 2 over 100 or 0.02. Okay, if we're increasing, okay, we're having something greater than the whole. Okay, so if we're increasing, then the multiplier becomes 1 plus that percentage. Okay, so it becomes 102% effectively. Okay, so that's your multiplier.
The worst calculator going.
Jesus.
2 seconds.
Okay, another way to write that, okay, we've got 100%, we're adding 2% on, the multiplier would just be 1.02. Okay, so if we're increasing, okay, that's our start percentage, that's our increase value, and we need to divide it by 100 to get our decimal. Okay, but that gets us our multiplier. So 2% increase, okay, means that, and we want to multiply it by a number greater than 1. Okay, so if we, after 1 year, say 3000 multiplied by 1.02, that's 3000 multiplied by 1.02, you put that in your calculator, okay, you get 3060. Okay. If after another year, okay, again, you start with 3060, so that becomes your new value. If it increases by 2%, do 3060 multiplied by 1.02. Okay, that becomes 3121.2. Okay, it's money, so the decimal's 0.20. Okay, if you want to do 3 years, your new start value would be 3121.2. Okay, multiplied by 1.02. Okay, so if I asked you for a short amount of time, so say it was 3 years, okay, if you wanted to do it this way, it increases by 2% every year. So you've got one whole one and 2% more. Okay. After 1 year, that becomes your new start value. After 2 years, after 3 years. Okay, so that multiplier stays the same. Okay, so if I ask you for a short period, something like 2 years or 3 years, that's a good way to do it. Okay, but you need to do it for every single part of that. Okay, break that down. Okay, so if it's increasing at 2% per year, the multiplier has to be applied every single year. Okay. Now, commonly they'll ask for something longer. Okay, so they'll ask something like 15 years. okay? And they're not expecting you to go 1 year, 2 years, 3 years, and use that multiplier every single time, okay? So we need a different way. Okay. So the different way is your new amount is going to equal your starting amount, okay, your whole value, multiplied by your multiplier, okay, and then that's going to be to the power of your number of years. Okay, so for the example above, your starting amount would be 3,000. Your multiplier is your 1.02. And for this, it's going to be the number of years is going to be 15. Okay, to the power of 15. Okay, so let's look at how we put that in our calculator. Okay,
Let's check both types of calculator. What are we on this?
okay. So if we want to do to the power of 15, there's a wee button in my Casio, okay, with an X with a wee square above it. Okay. An X with a wee square above it, a wee white out square. Okay, so that's the button I'm going to use to get to the power of something like the power of 15. Okay, so you may be familiar with the squared button, okay, but you're looking for, where is it in this one? There you go. Okay, so some calculators.
It's got log on it. 10 to the X in orange above it.
No, so I think Sandra, your one will be a wee arrow. So see beside x squared, is there a wee arrow, like a upwards pointing arrow?
No,
It looks like that.
no.
So the button on my calculator looks like X with a wee box above it like that. Okay.
Yeah.
On my other calculator, it's a button with that.
No,
Not there.
no. I'll research it later. Don't worry.
I don't even know what else it could be. In fact, are you on camera?
X to the 2.
No, that's x squared. So we've
Alright.
used that. Are you able to put it on camera?
The camera's off for some reason.
Yeah. The one and only time I ask you. Eh?
Oh, stop video.
Yeah, start video and then show me.
Alright, come on.
There we go. Right, let me
I don't know when
magnify
you
that.
won't be able to see it. No, you can't see anything, can you? It's too dark.
Way there, way there.
Yeah.
Yeah, take it back a wee bit. Right, hold it. Go up a wee bit. It's an interesting way of doing things, isn't it? Well, it really doesn't.
Doesn't, does it?
What's that far left, x to the minus 1? It's not that. There's that.
It's supposed to be a scientific calculator as well.
So see above the log button, what's that x to the power of? Go right from there, right. Other way. Yep, stop there. So x to the cubed, and then you've got x to the y, is that? So you've got x cubed, and then the one beside it, x to the
Y. The rules.
x to the y. Right, so I'm going to say, I think it's going to be the x to the y button.
Okay, I'll try
All
that.
right, so you've got, oh, you know that. X to the y. Right, okay, so if you use that button, and let's see if we get the right answer.
Okay.
Okay, so you're wanting to put in 3,000. Start with 3,000 multiplied by 1.02. Okay, and then we're going to press that button, which is going to give us a wee box above the 1.02, and in that we're going to type 15. Okay, and that's the amount of years. Press equals from that point, and we should get 4037.
376. Yep, that's it.
Is that us?
Yep.
Done. Okay, so
Thank you.
one of those three buttons, guys. So I'm using that button. Sandra and hopefully some others are using that one. Is anyone using that one and getting the correct answer? Just to double check.
Okay, just me. Thank you.
Right. If anyone's not getting 4037, okay, from that, so I'll just write that out a wee bit better. So new amount is equals our starting amount, which was our 3,000, multiplied by 1.02, which is our multiplier. Okay, so it's 1.02, which is our multiplier, and then to the power of 15. Okay, and that's the 15 is the amount of years. Okay, 15 is the amount of years. That's given us 4037. Okay, it's giving me that value. Okay. Try another one. Okay. So we say local council. Okay, local council. This is another example, by the way. Recycles 42,000.
That should be when it feels like.
Tons of waste per year. Okay. They look. Okay, so we've got local council who recycles a certain amount of waste every year. Okay, so 42,000 tonnes of waste every year. We want to increase that by 8%. Okay, so the whole figure is 42,000, and they want an additional 8% on top of that. Okay, so our multiplier is going to be 100% plus our 8%. Okay, so it's going to give us a total of 108%. Okay, if we're putting that in decimal, form, okay, we can write 8% as 8 over 100 or 0.08. So every year we're increasing by 0.08. Okay, so we need to add that on to our 1. Okay, so 108% is equal to 1.08. Okay, and that's our multiplier. Okay, it's a sort of roundabout way of doing it. Okay, the more, if you're familiar with it, okay, so probably overkill. Okay, but 108%. Okay. what will the total be 5 years and 10 years? Okay, so in 5 years, okay, we're going to do to the power of 5. So we're going to have our new amount. Oops. Can't spell tonight. Equals original value multiplied by our multiplier to the power of number of years. Okay, so original value is 42,000. Our multiplier is 1.08. Okay, 8% increase every year. And the first value we want to find is after 5 years. Okay, so 42,000 multiplied by 1.08 to the power of 5. Okay, and I'm getting 61,711.8 tons. Okay, so that's after 5 years. After 10 years, same calculation, 1.08, this time to the power of 10. Okay, so same calculation, times 1.08, power of 10. And we've increased way up, 90,674.8 tons. Okay, so you can see how that keeps increasing and increasing. Oh, sorry, no trouble. Okay, so we've increased that. So we've taken our multiplier, okay, 1.08, we're increasing it. After 10 years, we're getting 90,674 tons. Okay, let's have a wee look. If anyone's still copying that, give me a wee shout. Oh, that's the wrong booklet. This is the wrong booklet. That's pack 2, where's pack 3? Okay, pack 3, working with percentages. Okay, so pack 3 in middle. Okay, I'm on page 45. Okay, so amounts have been reduced by 15%. What was the original amount? So don't do that. What am I looking at? Appreciation, depreciation. Okay, sorry, I'm looking at page 47. Okay, question 1, just a bit of a pain. Okay, that's what we got to. Okay, so question 3 is very similar to what we've done. So buying a house for 60,000, if it appreciates at a value of 9% per year, how much will be worth in 5 years' time? Okay, so we should be able to do that. 200 and some jewelry, appreciates 2%. 4 is the same. 5 is the same. Okay, so 3, 4, 5, 6. 3, 4, and 5 really, is that? Okay, because we've not done depreciation. Okay, so if we do question 3, 4, and 5, okay, if you work on that, do that only. Okay, have a wee think about question 2. Okay, have a think about question 2 and see if you can work that out. Okay, remember the answers are at the back if you've got this open. I'll leave this on the screen, okay? So, but if you can do question 3, 4 and 5, okay, then we'll take a break and we'll come back together at 20, say a 20-minute break. So we come back together at 20 to 8. Okay, so if you do question 3, 4 and 5 and then take a wee 20-minute break. Okay, answers at the back if you can open it up. It's page 47 in pack 3. Okay, but I will keep that up as best as I can. Yeah, the back. Okay. Fall of 30% means we've got 70% of the original. Okay. Taking that final number of students, divide it by 70 to get our 1%. Multiplying our 1% by 100 to get our total or final value, okay, or original value. Okay, so 343 students started in that course. Okay, now we could also increase. Okay, so you might also get asked. Okay. Price of a washing machine, nice obscure one. Was £420 after a 5% installation fee was applied, was added. Okay. Find the cost of the machine before installation. Okay, so again that 420 is our final value. Okay, that's after a 5% installation fee. So we've now actually got an increase from original 5%. Okay, or another way to put that, we've got 105% of original value. Okay, so 420 we want to find 1% of. So we're dividing that by 105. So 420 divided by 105 is 4. Okay, so that's our 1%. Okay, find the original price, we're multiplying 4 by 100. Okay, so 100%. We take 1% and we multiply that by 100. Give us 400. Okay, so original cost of machine before installation is £400. Okay, so that just shows the one that's just shown it increased. Okay. Now again, if you want to double check that and you wanted to find the multiplier, okay, you could divide that by 1.05. Multiply that by 1.05. Okay, if you multiply 400 by 1.05, you're going to get 420. Okay, so it's that 5% installation fee, okay, that was added on. That is as tricky as percentages come. And I've tried my best to confuse you. I don't think they were particularly well explained. Okay, so Going back, so starting on page, remember this is pack 3 on page 45. Okay. These amounts have been reduced by 15%. What was the original? Okay, so £85 is 85% of the original value. Okay, so dividing that by 85 takes it to £1. So 1% of that is £1. Okay, so the original amount for question 1A would have been £100. Okay. There's some where they've increased. Okay, so we've now got 122% of that value. Okay, so to find 1% of that, we'd divide it by 122, then multiply it by 100 to find out what the original amount was. Okay. That's 20% off, so that will be 80% of the original. Not too bad. 7% rise. Hey. It's what people are after this year, isn't it? So 7% rise. Calculate what people are earning before the increase. Okay. So they've got 107% of what the original was. Okay, so that's a wee increase. Exam level questions, membership is increased by 17%. Oh, sorry, memberships. It's now got 585, so that's, if you do 585 divided by 117 to find 1%. Okay, and then multiply by 100. So there's nothing outrageous here. That's fine, there's nothing, just looking out for anything tricky. Okay, any like different layers of it. It doesn't seem to be anything outrageous. These questions don't tend to be. What I would be careful of, and what may be worthwhile practicing, is these non-calculator ones. Alright. Finding a fifth of 1 million was a wee bit more awkward than we probably wanted it to be. Where's the other non-calculator one? Okay, so there we go, a fifth again. Okay, so if it's non-calculator, they will use a common fraction, okay, a common percentage. So 10%, 20%, 25%, 50%, okay. Just be aware of them. So 20% seems to be a popular one for non-calculators. Let's have a wee look at this one. And there's 10%. Okay. So if you got that in your non-calculator paper, I'd be expected you to, okay, just do that pretty comfortably. Okay. Worthwhile just having a wee go at them, and if you're struggling, then it's certainly something we can revisit. Okay, so any non-calculator ones are flagged up as non-calculator. Okay, that is percentages.